challenge from 2020. It's out of 25 in terms of how many questions there are. Assuming that you didn't get any wrong, because you lose a mark if you get a question wrong, you only need 9 correct answers to get a bronze, you needed 12 to get a silver, and you needed about 17 to get a gold. Really focus, therefore, on the first 15 questions. As you'll see, a lot of them aren't even that tough, and you can get a silver award just for focusing on those. If you are going to get into the golds, you do need to get into some of the more difficult questions, obviously. And when it comes to guessing, like I said, you lose a mark if you guess one wrong. You gain 4 marks for getting a question correct. So therefore, because each multiple choice question is out of 5, it's not efficient to guess a question you have no idea about, because you're more likely to lose than gain. But if you've got it down to like a 1 in 3, then probability says it's probably better to guess then, because you gain 4 if you get it right, and you've got a more than 25% chance of getting it right, and you only lose 1 if it's wrong. So if you somehow eliminate the options down a little bit, and it's down to a 1 in 3 or a 1 in 2, you can probably then give it a guess, because you are more likely to gain marks than lose them. Okay, let's get straight into it then. So the first few questions are not too difficult. When you're doing this kind of thing, you get questions like this all the time. Do not just do the maths. It never wants you to just do the numeracy. Simplify 10 out of 12 for me. Well, obviously 10 is just 5 times 2 and 12 is 6 times 2. Then you spot these 2's and you cancel them. Now, of course, that's not how anyone really does this, but that's how it's actually working. That's how it goes on. So here, what I can say is 2020 is just 20, is 10 times 202, which is 20 times 101, just moving one of the factors of 2 out to this one. And then, of course, I can just cancel these 20's in the same way that I cancel with these. 101 divided by 20 is 10.1 divided by 2, which is 5.05. You want to be really good at your numeracy, your fractions, your dividing by 20, like divide by 10 first, then divide by 2 kind of thing. I'm going to try and run through these first few questions though, because otherwise this video will be very long. Anyway, question number 2. What's the remainder? So this has remainder 4 when divided by 5, and that has remainder 3 when divided by 5, clearly, because it's 4 above 0 and this is 3 above 5. You can just times the remainders together to make 12, and that has remainder 2 when divided by 5. So the answer is remainder 2. The other way you could have done it is just, if you were to multiply these out, and again, you'd never actually want to do that in the math challenge, but if you were to do this, 4 times 8 comes 32, and that would mean that the last thing would be a 2 from the 32, which of course means the remainder is 2 when you divide by 5. Okay, so the remainder is 2 either way you do that. This just literally just count the faces. Like, if you came to this video for help on this question, then I worry for you. But seriously, just look at the picture and count them, right? There are 5 on top, which means there are 5 on bottom, so that's 10 in total. Then just count around the edge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 10 is 22. If you want to do it desperately in some mathematical way, each cube has a surface 6. There are 5 cubes, so 5 and 6 is 30. But then 1, 2, 3, 4, 5, 6, 7, 8 sides are up against each other and aren't facing anywhere, so you take away 8 and you get 22. But sure. Okay, question 4. Again, this one really straightforward. This is where you want to get the marks. If P is 2, clearly that means Q is 10. Clearly that means 2 times 10 is 20. Divide this by 20 again. Just divide it by 10, then divide it by 2. So divide that by 10 to get 20.2, then divide it by 2 for 10.1. Here, I don't even need to put these back in, because I know P times Q times R is 202, so I can just replace those with 202. Clearly makes S 10, and then just obviously add together 10, 10, 10.1, and the original 2 that they gave you, and you get 32.1. Good. Question 5. This one's quite a nice one. Now, you're not expected to know the algorithm for square rooting any number. There is one, but it would take you quite a long time, and it's not worth learning in any way. It's just for hyper nerds like myself to know. So don't just square root this without any help. What you want to do is notice that all the answers look like this. Now, I know 11 squared is 121. Hopefully I just know that from primary school. Now, I can work out without too much effort that 111 squared is 12321. I can just do a little grid multiplication or whatever. And what I'm going to do here is I'm just going to hope that, oh, this looks quite nice. That means when you do 4 ones, that probably squares to this, just spotting the pattern. And I'm just going to assume that this is true. Right, which means 5 ones square to this, which of course means if 5 ones square to that, then the square root of that is the 5 ones, and it gets me the answer there. So use the answers to your advantage whenever you're doing math challenges. They're there for a reason. Please use them. Question number 6. There are less than 30 students, or fewer, I should probably say, in a class. Half of them play piano. So this is, whatever the number is, I need to be able to halve it. So there can't be 29 students, because if I halved it, I'd get 14.5 playing the piano. So I need a number less than 30, an integer of course, that I can halve for an integer, that I can quarter for an integer, and that I can divide in 7 for an integer. So in other words, this number has got to be a multiple of 2, 4, and 7. And the smallest number that does that is 28, because it's just 4 times 7. Now, if there are 28 students, how many of them play hockey? Well, it says a quarter play hockey, so a quarter of 28 is 7. Good. Question 7. Okay, so it's talking about percentage reduction, percentage decrease, so I'm going to have to use the GCSE percentage decrease formula at some point. It says approximate though, so let's approximate these. Let's make that 200, and let's make that 50. And then let's use the percentage change formula from GCSE, new minus old, or original, divided by original, times 100. Well, the new one is 50, so it's 50 minus 200 over 200 times 100. That makes minus 150. I can just do the 100 divided by 200 instead of this. I mean, this is just 3/4 clearly, times 100 is 75, but whatever. However you feel comfortable doing that, that's a 75% decrease. Now, the problem with that answer is that it's exactly in between two of them, but just look at my approximations for a second. I brought the old number down, and I've brought the new number up. I've brought these numbers both closer to each other. So this is an underestimate of the, is an underestimate of the percentage decrease? Yeah, it's an underestimate of the percentage decrease because it's I've used numbers that are close together, right? The actual percentage decrease uses two numbers that are further apart, so the reduction must be more than this. So I round this up to 80 rather than down to 70. The other way you could do that is you could test what happened if you rounded that to 250 and just did everything the same but with two 50s here, and you'd get something like 85% or whatever, and then you knew the actual answer would be in between your two, and it's 80. But either way, 80. Okay, again, do not do this unless you want to be an absolute pleb. Of course you do this, that factorizes to this. I can just use this as A and this as B, which means this is equal to this. This is nice because it's just this. I'm looking for prime factors here. Well, 11 times 11 is 121. 91 can't be prime, because otherwise it would be the answer. So I must be looking for two things that multiply to make 91. Eventually, after doing a bit of bust up, I found that 7 times 13 is, because I just don't know this one off the top of my head, but I probably should. Anyway, that means that this thing here is equal to 7 times 11 squared times 13, the largest prime factor, of course, being 13. Good. Question number 9. So, yeah, using the DRS system, you can do it if a car is 1 second or less ahead of you. Suppose that cars are exactly a second apart, traveling at that speed in the same direction. How many meters? Well, speed equals distance over time. We're looking for distance, right? So distance is speed times time. So all I need to do is times the speed times the time. The time is 1 second, so that's super easy. But of course, they're looking for meters, and they're giving me a speed in seconds, and they're giving me the time in seconds, but the speed in hours. So I need to convert some stuff around. So that there, need to make it into meters first. So that's going to be 180,000 meters per hour. Because, of course, 1 kilometer is just 1,000 meters, so I put the 1,000 in. Divide that by 60 to find how much per minute. So dividing that by 60 is nice because it's just 180 divided by 60 is 3, and so it's just 3,000. Divide it again by 60 to find per second. Again, dividing that by 60 is nice. The zeros cancel. 300 divided by 6 is 50. So it's 50 meters per second for 1 second means the distance is 50. So the answer is B. Excellent. Number 10. Okay, 6 people, so let's put a line of 6 and use the information. So 3 people between Pat and Kazim. I'm just going to use the initials of the letters. So 3 people between P and Q means if P was here, Q would have to be 1, 2, 3, Q is down here. The only other option is that P is there and Q is all the way over there. Now, of course, they could be the other way around. Q could be here and P could be over there. But I'm assuming that the symmetry is not really going to matter. I'll deal with it at the end if it does, but for now I'll just leave it like this. Okay, so there are 2 people between Kazim and Ronan, so 2 people between Q and R, so R could, in this example, go here, because that puts 2 people in between. In this one, R has to go here, because again, that puts 2 people in between. And then 1 person between R and S. So in this example, S would have to go here, because there's 1 person in between that way. And in this example, S can actually go here, where there's 1 person in between, or over there. Except over here it says that Sam is not the either end of the line, so Sam can't be there, which means these are the only 2 cases. And it's a bit weird because we have two acceptable cases, but it's fine because how many are in between t and u? Well, in either case, there are two people in between t and u, right? In this case, s and q, or in this case, p and r. There's two people in either side, so yeah, the answer is C. Question number 11. Okay, so the side lengths are 1, apparently, and it's asking me for the perimeter of this entire shape. Well, okay, that's also 1, which means I can immediately tell the perimeter is more than 1, 2, 3, 4 because of all these extra bits. So that's definitely not the answer. But this distance here, this cut-out length, that's 1. And this is a right-angled isosceles triangle, which means that if that's x and that's x, then x squared plus x squared is 1 squared, 2x squared is 1 squared, divided by 2 square root. And you can also rationalize that if you want to. Now, of course, that means that this length here is also the same. That's also root 2 over 2. Sorry, that's root 2 over 2, which means this little length here, because the whole thing is 1 minus that. And now I've got everything I need, right? The perimeter is going to be this, plus this, plus this, plus the 2 red bits, plus the 2 blue bits. But now something nice, really nice happens, which is this cancels with this cancels with this, and we just end up with 6 ones, and that's the answer. It's of note that you could have just labelled this R, or X. You could have labelled it X, but not bother to work out what it was, because if that's X, then like I said, this length is X, which means that's 1 minus X, and then everything cancels without having to have done this work. But regardless, who cares? Question 12. Okay, so you've got a suit, trousers and waistcoat. What's the cost of a three-piece suit? So you're trying to work out j plus t plus w. What you're given is that 2j plus 3t is 380, and you're also given that t, because a pair of trousers is just a single t, I'm saying, because that's what is in the thing. It's just an English thing that we say pair of, even though there's just one of them. Cost the same as 2 waistcoats. So this is what they've given us. This is what we want. We want the sum of a three-piece suit. Okay, so how do we do this? Well, we do an extra cheeky move, which is to say that 3t is the same as t plus 2t. So just using this, just breaking that up. But I've coloured this red, of course, because I can just replace that with a 2w. And now once I divide by 2, I find my answer of 180. And I really like questions like that, where I haven't at any point even bothered to work out what any of those three things cost. I've just kind of circumvented the problem entirely. I like that. Anyway, question number 13. Okay, so let's define an odd integer. Now, an odd integer is a number that doesn't have 2 in its prime factorization. So things like 33, it's just missing a 2. It can use any prime it wants, it just can't use a 2. That's what odd numbers are. Okay, so apparently this is odd, which means this number here, 16 factorial divided by 2 to the power k, doesn't have any 2's in its prime factorization at all. Now, 16 factorial, as it says here, is 16 times all the numbers below it. And 2 to the power k is obviously 2 times itself, k times. There are k2's here. I just can't be bothered to type the things in. I mean, I can't type this because I don't know how many there are, but I can't be bothered to type things in between here, stop at the dots. Now, what we want to do, again, this is about prime factorization, so let's change 16 to be 2 to the power something. Well, not just that, but let's change it to its prime factorization. So this is 2 to the power 4, but this is 3 times 5, this is 2 times 7, and so on all the way down. And what I want, if I want this to be odd, is I don't want there to be any 2's in the prime factorization. So what I want is I want all of the 2's on the top row to cancel with all the 2's on the bottom row, and therefore just leave me with odd primes on the top to make my number. So I just need k to equal, k of course being the number of 2's here, because of that. I just want that to equal the number of 2's on the top row. So how many 2's are there on the top row? We'll just count what each number gives you. So 16, I've already said, gives me 4 2's. 15 doesn't give me any. 14 gives me 1. 13 obviously doesn't give me any. 12 gives me 2 because it's 2 times 2 times 3 is its prime factorization. 11, none obviously because it's odd. 10 gives me 1 because it's 2 times 5. 8 gives me 3 because it's 2 times 2 times 2. 6 just gives me 1 because it's 2 times 3. 4 gives me 2 because it's 2 times 2. And 2 just gives me 1 because it's just a 2. Total that up, and you find there are 15 2's in the top row when you write it out as a prime factorization, which means I need 15 on the bottom row to precisely cancel them all, and therefore end me up with an odd integer. So I need 15 of them, which is the answer D. Question 14. Yeah, this is the first one that I really stopped to have to think about. So I think a lot of people probably also had problems on this, unless it's just the kind of question that I'm quite bad at, which is also probably completely true. Okay, so you've got 5 blues, 2 reds, and a yellow. Now, the only one that you're given any actual information of is is red. Like, you're not allowed to put a red disk next to another red disk with a common edge. You can do it diagonally, but not with a common edge. So let's place the reds first. If I put reds in the corner, like so. There are 1, 2, 3, 4, 5 other places that I can put a red, and I'm doing that there. The only places I can't put a red, if a red goes in the corner first, is here or here. Right, so there are 5 other places for them. So that's all that. Now, if I instead put a red in one of the middle sections, like one of these middle 4, like I'm doing here, there are actually only, well now, I can't put it here, here, or here, so there's only 1, 2, 3, 4 places left for it to go, as signified here. And of course, all the other corners and all the other middles will be entirely the same, right? If you start by putting it here, there's going to be 5 options you can put it in, and if you start by putting it here, maybe, there's going to be another 4 you can put the other one in. So if you start in a corner, there are 5 ways to put the other red, and there are 4 corners, so that's 4 times 5 is 20 combinations. And if you start in one of the middle bits, there's only 4 places to put in the other red. And there are 4 middle bits to start in, so 4 times 4 gives you 16 combinations. 20 plus 16 gives you 36 ways to put the reds down, except that you're going to have you're going to have repeated cases. For example, when you put this one up in the corner here, and then you also put one down here, say, so this case, that's going to be the same as when you start by putting your red here, and then put the other red here. Right, so you're always going to have these repeated pairs. So you have to halve this down to saying there are 18 ways to put the reds. And that's actually the most difficult bit of this done. Now that you've decided how many to put the reds down, how many ways there are to put the reds in there, and what you can do, why have I done this? Oh, sorry, yeah. What you can do is, for any red that you have, so let's just take this, let's just run with this configuration of reds. Now remember, there are 18 ways to put the reds down in total. Let's run with this combination. How many ways are there for me to finish this off? Well, the blues are all the same, they don't matter. So it just depends where I put the yellow. And there are 1, 2, 3, 4, 5, 6 places to put the yellows. So I've put them all down here. So for each configure, and then when you put the blues in, of course, it just fills it out, right? Nothing happens. So for each way to put the reds in, of which there are 18, there are 6 ways to finish it off by just putting the yellow in the one of 6 boxes left. So 18 times 6 gives you 108, and that'll be how many there are. I thought that was quite a difficult question, particularly for the first 15. Okay, I should finally note actually, and this is the kind of meta-awareness that you want to have. I'm happy with this because doubling it gives me an answer that they think people might choose. And remember, the hardest thing about this maybe was to say, oh, I needed to halve my answer for the repeats of reds, and if you forgot to do that, you'd end up with the answer 36 times 6, which is 216, and so that's why that answer is there, to try and trip those people up. So I'm happy that it's half of an answer that's there as well. I think that is probably a good thing. So that's the kind of meta-awareness that you might want to develop as you practice these papers. Question 15. More meta-awareness is going to come up here to save you some work. But okay, so this circle has radius 3, which is cool. It's also obviously tangents meet radiuses at 90 degrees, so there's 90 degrees in there. Let's split this into 2 and say there's 30 degrees either side. And what I've done there is I've made 2 congruent triangles with angles of 30 at the top here, sides of 3 down at the bottom, angles of 60, of course, down here, because there's a right angle and that just gives me 60 left over. So that's just each of these 2 triangles. I want to work out the area of those 2 triangles, obviously. Well, okay, I can just say that tan, did I use tan? Yeah, I can just say that tan 60 is x over 3, opposite over adjacent. I need to know that tan 60 is root 3. Timesing by 3 makes x 3 root 3. So both of these diagonal sides are 3 root 3, which of course means the area of each one of these triangles is half times 3 root 3, because they're perpendicular. And that makes 9, and then divide by 2. Now I can actually stop here, because I've only worked out the triangle bits here, so I still need this kind of sector of a circle down the bottom here. But I know that that sector is just going to give me an answer in terms of pi, so it's not going to give me any root 3s or anything. So the fact that my area is 9 root 3 over 2 means the final answer is going to be 9 root 3 over 2 plus some number of pi's, and the only answer that does that, oh sorry, I haven't quite finished right, that's the area of one of the triangles. So when I times that by 2, the area for both is 9 root 3, and the only answer with a 9 root 3 in it plus some number of pi's is a, so the answer must be a. I don't have to do this. I can do, obviously, like radius 3, that angle is 120, 240, so I can do this, but I knew the answer was this because it's the only one that contains this. I just forgot to double that because there's 2 triangles, so just double it to say that the area of both triangles is 9 root 3. Sorry about that, but yeah, sure. I was just making the point there that you can stop as soon as you see the 9 root 3. It must have been this answer. But you can work this up out if you want to as well. 16, whenever I see a question like this, I just look for key points. So, when you match a graph to an equation, just what happens when y is 0? Let's just start with. Apparently, let's just start with what happens when x is 0. So when x is 0, you're not moving left or right. Your coordinate isn't going here. So we're just essentially looking for points on the y-axis here. So okay, let's just put those in. So x is 0 obviously makes this whole thing 0. Factorize out the y and we get two answers. Y is 2 or 0, which means we're looking for a graph that goes through the y-axis at both 0 and 2. So that one does, that one probably does, that one definitely doesn't, that one definitely doesn't, and that one probably does. So we've eliminated those two. We'll play the same game with y equals 0. So now we're looking for, if y is 0, we're not going up or down, so we're looking for x-intercepts here. Just put that in, a very similar thing, factorize, and we get answers of x is minus 2 or 0. So it intercepts the x-axis at minus 2 and 0, so it can't be this, it could be that, and it could also be that. Now what's the difference between these two? Well, these two kind of intersect at a point, and these two don't. Now just doing some guesswork here, that I know is 2, or should be, and that's 0. So it looks like when y is 1, we shouldn't really get an answer. Like x doesn't give us an answer, right? Halfway in between here. That's where that gap is. So let's just ask, what happens when y is 1, according to the algebra? Well, 1 squared is 1, minus 2 is minus 1. Put that over and factorize, and you get an answer for x. X becomes minus 1. So I think it must be this graph, because when y is 1, we actually do get an answer of x is minus 1. Whereas here, there appears to be a gap, which I can't really justify being here, so I think the answer must be E. Now, there are more clever ways of doing that, but again, this is a math challenge. You don't have that much time per question. Sometimes you just want to use a bit of intuition and use a bit of feel, and don't do anything too complicated. So yeah, I think that's an acceptable way of doing it. Question number 17, again, this is also going to be me kind of just fudging some maths together because I can't be bothered to do it properly. I sort of thought about doing it properly first. I put these two things together, and then I tried this p can just jump up to there, and then I multiplied out by the np plus 1, and I sort of thought about expanding like this, and then I factorized, and I thought, well, if these two things are equal, this has got to be a multiple of 17, and this has got to be a multiple of 3, because otherwise you're not matching the prime factors. And I thought about that for a bit, but it seemed like I was doing much too much work. And again, you shouldn't really have to dive too deep into number theory to do a senior math challenge. So instead, I was just like, well, okay, what just happens if m is 1? Like, I know they're positive integers, so let's just choose some random stuff. What happens if m is 1? Well, I get this. I've put this into mp plus 1, just because this is just np over p, and then I can just put it together. Now the problem with this, when I kind of move take away 3 from both sides and then multiply across, is that n is a positive integer. So the lowest it can be is 1. But if it is 1, then you get 3p is 14p plus 14, and this side is much too big, right? Because p is also a positive integer. So this side is just much, much too big. So this just can't be right. So m just can't be 1. If these are positive integers. And then you just do it again, right? If m is 2, you just do the same thing, and you still end up with something way too big over here. Like miles too big. So okay, you just move on. What happens if m is 3? Well, again, you still end up with stuff that's too big, right? This is definitely not going to have a solution for positive integers n and p, because this side is just much too big over this side, so that doesn't work. M is 4. You run into the same problem, right? Even if n was 1, which is the lowest it can be, you'd end up taking away 5p from both sides and get minus 2p as 5. It still doesn't work. So then you finally end up with m is 5, and you end up with something that might actually work. Because here, if you select n to be 1, which you're allowed to, you get this, and then p is equal to 2. So yeah, p is 2. I found a solution. So again, a bit of fudging there, but again, you've got to have that sort of sixth sense for when you're doing stuff that's just a bit too complicated, and maybe there's an easier way to do it. So again, if you're given something so restrictive like positive integer, just try some stuff. Maybe that'll work. Question number 18, two circles have centers at 3, 4. Okay, so if we just quickly sketch this, there's maybe 3, 4. So we've got one circle and maybe a bigger circle, and they both touch a third circle, which means the third circle must kind of be trapped in between the two. So they both just touch it. The center of the third circle is at 0, 0, so this picture is clearly terrible. What it actually looks like is maybe a bit more like this. So the third circle, you'll forgive my PowerPoint skills, does just touch the other two circles and has its center at 0, 0. And now that radius is 2. Now, I know that this point is 3, 4, which means the distance from the origin to this point is 5, and again, you'll have to forgive me for the terrible out-of-scale picture, but that distance is 5 because it's just 3 squared plus 4 squared, and I know a 3, 4, 5 triangle when I see one. Which of course means that this distance is 3, because it's just 3 plus 2 must be 5. Now I know this distance is also 2, because a circle has the same radius all the way around, which makes this whole distance all the way along equal to 7, which means the radius of the big circle is 7, the radius of the small circle is 3, and I add them together for a radius of 10. Excellent. Question 19. I liked the way that I did this question, even though I was just doing more fudging of stuff. P minus Q is R, R is S, minus S is T, so R is S plus T, I think, or T plus S. Which means P minus Q is T plus S, which means P minus Q minus S is T. And the reason I did that is because I'm looking for different values of T. So I need P, Q, R, S, and T to all have different positive single-digit numbers. Again, when I saw this, I just thought, I can just try stuff. It's so limiting that I can just try stuff. Let's just try and make different values of T. So if they're single digits, so we're lower than 10. And positive, so they're not 0. So I just figured out that if P was 9, Q was 6, and S was 2, I can get T to be 1. Now I also need to double check. This equation here doesn't have R in it, and R does need to be different. But R is of course P minus Q, so it's just the first bit. Go away. So it's just the first bit of this. So it's going to be 9 minus 6, so R is 3. So that does indeed, and that's okay. I can also just lower this by 1 to get T as 2, so that's the second value T can take. Again, R is 3 here because it's 9 minus 6. And I just kept writing in random numbers to get loads of different values of T. So I can make 3 this way, R becomes 4 like that. I can get T as 4 this way, R is 7 this way, so that's again different to the other 4. And then I can also make 5 by doing this. R is 7 again, which is fine because it's different to all of these. And I can finally also make 6 by doing that, and R is 8. And they're all different, and so I can make 6 different values of T. I know I can't make 7 because the highest number I can use here is 9, and then I'd have to use 2 1s to make a 7. I can't use a 0 because they're positive. And then the 2 1s would be the same as each other, so that's not allowed. So it's 6. Also, more obviously, I know the answer isn't 7 because it's not in the list. So yeah, the answer is 6. Question 20. This one is annoying. When I first saw it, I thought it would be a really nice question because it's indices and I like indices. Turns out to be just an enormous pain. This is one of those questions where you want to make the base the same everywhere. So this is 2 squared to the y. Like I want to make the base 2. 1 over is the same as to the power minus 1. Now I'm going to distribute this minus 1 to both things in the product, which is the 8 and the root 2 to this. So timesing the minus 1 by this, because you times, don't you, is minus x minus 2. And then the minus 1 can also be part of this 8, so it's 8 to the power minus 1. This 2 squared becomes a 2 to the 2y. And then again, I just need to turn these two things into 2's as well. So this is 2 to the half, this is 2 cubed. You'll forgive me for writing a half as a decimal just because I can't be able to do fractions in PowerPoint. This makes 2 to the power minus 3. This makes 2 to the minus half x minus 1. And then of course we add indices when we're multiplying. So it's going to be minus a half x minus 4. Which of course means that 2y is equal to that. And I'm just going to get rid of the decimal and leave it like this. The other one is a bit easier. This is 3 squared x. In fact, I'm going to move the x over apparently as well. This is 3 squared x times 3 to the y equals 3 to the 1.5, because that's 3 to the 1 times 3 to the half, and then you add them together for 1.5. That makes this, which of course means 2x plus y is 1.5. This is a simultaneous equation. I don't know what I did here. I times this one by 2 apparently to get rid of the decimal. And then what did I do? Times this by 4 to match the x's. And then I did this, take away this to get 14y equals minus 35. Oh, and then I panicked for like 30 seconds because I thought, oh, that's not a nice number. I've done something wrong. But it's not that bad a number. It's minus 5 over 2 or minus 2.5. And it turns out when you put that into here, you end up with a good answer for x. 4 times minus 2.5 is minus 10. Add 8 to both sides to get minus 2. So minus 2 is minus x, which means x is 2. And then of course x plus y therefore is just minus a half. And 5 to the minus a half is 1 over root 5, which is an answer. So I panicked when I saw this because I thought I'd made a mistake, but it was just the question writer being a pain, because it is correct. Okay, question 21. When written in full, that has a lot of digits. What's the sum of all of the digits? Okay, well, let's expand this out. So this is squared as just this times itself. This times this, of course, you add the indices. Again, we just saw that, so that's 10 to the power 4040. Then we're going to have two copies of this times this, so two copies of this bit times this bit, and then we're going to have this bit squared. Now this is just 1 followed by an absolute ton of zeros. So the sum of all the digits of this bit is just 1, because it's 1 followed by a ton of zeros. This is not too bad to work out, it's that, which means the sum of the digits that this contributes is 16. 4 plus 4 plus 12. Sorry, 4 plus 4 plus 8 is 16. So this is contributing 1 to the total sum. This is contributing 16. What about this middle bit? Well, 10 to the power 2020 is just 1 followed by a ton of zeros. If I times that by 2020, I get 2020 followed by that same number of zeros. And if I times that by 2, I get 4040 followed by the same number of zeros. So this contributes simply 2 4s, which is 8 to the sum. And so the total sum of digits is 1, 16, and 8 to make 25. And yeah, I mean, that's it. Cool, 22. Okay, so perimeter 4 means that each of these sides is 1. Cool. If I label, notice that that means that this distance here is 1, the base of one of these triangles, so that distance there is 1. If I label the height of the triangle x, that of course means that's x. And importantly, that means that the smaller side of the trapezium is also x, so that's that length there and there. And what I'm doing here is I'm saying, well, if that's x, then this length is 1 minus x. And so the base of the trapezium is 1 minus x. So I did that, I said it in the wrong order, but hopefully it's clear what I've done there. If that's x, then that's x, which makes this x the smaller length. Now, if that's x, then this is 1 minus x, because this whole side is 1, and that can go there. Now, lastly, what about this length here, this larger side of the trapezium? Well, that's also 1 minus x, right? And the reason that it's 1 minus x is because, well, I'm stalling for time because I can't quite remember why it's 1 minus x. But it definitely is. I can definitely say, hand on heart, that this length is definitely 1 minus x. I just need to try and figure out how I know that, because I can't remember. Oh, of course, because of this side here, right? If this is 1 and this is x, then this here is 1 minus x, which is the same as this here, which means this taller side of the trapezium is 1 minus x. And now, well, what I can notice here is that it's asking me for the perimeter of this. Well, the perimeter of this is 1 plus 1 minus x plus 1 minus x plus 1 plus 1 minus x plus 1 minus x, or 2 times these three things added is what I did, which is much smarter, which actually just ends up being this. So if I just knew x, I could quickly substitute x in, and that would be fine. So let's try and figure out how to find x. There are two ways to do this, but the way that I did it, in fact there's probably more than that, but the way that I did it is notice that this triangle is similar, of course, to the whole triangle here, which means this side over this side in the smaller triangle must equal this side over this side in the bigger one. So x divided by 1 must equal 1 minus x divided by 1 plus 1 minus x. Of course, that's just x, and this is just 1 minus x over 2 minus x. Because in similar shapes, the ratio of the sides is the same. So x over 1 is the same as this over all of that. Now, times by sides by 2 minus x. Solve this. I use the quadratic formula. I don't know what you wanted to use, and the answer is this. Now, of course, there are two answers here, but we know which one it is, because 3 plus root 5 over 2 is much bigger than 1, and x has to be smaller than 1. So the correct one is going to be 3 minus root 5 over 2. And I can actually stop here. Again, this is why you want to be aware of the answers in the questions, because if I'm going to put this into here, obviously, but that's going to give me an answer in terms of root 5, and the only answer that has a root 5 is this, so I know the answer is A. Now I can do it if I want to, and for completeness, there it is, but the answer is 2 root 5, and again, just to save yourself 3 minutes of work, maybe just notice, if that's your answer, it must be this, because nothing else has a root 5. Okay, question 23, this is a nice question as well. It's interesting because you don't really get taught functions properly at GCSE, because the scheme of work is so terrible. Which means that you're very unprepared to answer questions like this, and A-level doesn't talk enough about functions either. So I think generally people find this type of question quite hard. But yeah, I think they're really nice. I mean, I can't explain why I did this, but when I looked at this, what my brain did was it said, well, actually, wouldn't it be easier to work out this? And I can't explain why my brain said that, but it did, and it turned out that this does sort of help in a little way. All I've done is I split the two things into two fractions. Now, what I need is I obviously need f of 20, f of 2, and f of 3. Even if I hadn't thought of this, like, I just need f of 20, f of 2, and f of 3 somehow. So, okay, taking this equation then, I need to substitute in 20, 2, and 3. So let's start with 2 because it's the smallest. But what I noticed, and this is what I tried first, is if you put in x is 2 and y is 2, you get this amazing equation here, where 2 cubed of f of 2 is equal to 2 cubed f of 2, and incredible work. Really helpful there. So what you need to think is, okay, well that wasn't very helpful. I just need to mix and match them then. Let's use 2 and 3 first, and then let's swap them over. So if x is 2 and y is 3, then I get 3 cubed into f of 2 equals 2 cubed f of 3, which is this. And now I noticed, well actually, looking at my sixth sense thing, if I just reverse cross multiply to get this, so divide both sides by f of 3, divide both sides by 27, that's one of the things that I need. So that's cool. And I can play the same game now with, well, the other thing is 20 and 3. So using x is 20 this time, y is 3. Put those in, 20 cubed is 8,000 by the way. Do that reverse cross multiplying thing, and you get this. And now I just need to do this one, take away this one, and that'll be my answer. And I stared at this for a while thinking of an intelligent way to do this, but I couldn't, so I just did it. If you're ever dividing by a big number, just divide by 2 factors. So get out a bus stop, divide that by 9 or 3, and then divide it by the other one. So because 3 times 9 makes 27, I can just divide by 1 then the other, and anyway you get 26. Probably want to be pretty good at bus stop, because imagine doing this whole question and then not knowing how to divide this properly. So yeah, useful tricks there, but the answer is 296. Question 24, again a nice question. Let's just write down everything they've told us in order. So this is a midpoint. The line PS bisects RPQ. So that means that this angle is the same as this angle, which I will put down in a second. It also tells me the length of PQ is 12. But M is the midpoint, so that's 6, and that's 6. The angle is bisected, like I said, so that's x and that's x. The length MT is 1, so that little length there is 1, which means I'm actually just going to get rid of this 6 and put a 5 down there, because that of course makes that whole thing 6 up to the midpoint. Okay, and what haven't I used now then? What information haven't I used? The line ST is parallel to PR. What that means is that this angle is corresponding to this angle, because this line is parallel to that one. So this angle here is 2x. Now the reason that's really helpful is because what that means is that this angle on the other side of it is 180 minus 2x. And that opens up a huge door, because then if you look at this triangle PST, you currently have angles 180 minus 2x, x, which if you do a bit of 180 minus the other two, gives you that this angle is x. Now it's obvious when I put it in, because x plus 180 minus 2x is of course 180. But that's great, because it means that this triangle PST is isosceles, which means that this length is the same as this length. And just be careful, because this triangle ends at T, right, not an M, which means this length is 7, right, because it's 6 plus the little 1. So that length is 7. I know this length is 5, and I know that angle is 120. I'm looking for SQ. So if I just draw the triangle out like this, it becomes more obvious what I need to do. I can just do cosine rule on this. So I know that 7 squared equals 5 squared plus y squared minus 2 times 5, so the 2 is just part of the formula, times 5 times y times cos of 120. Some of this is easy to do. Obviously 2 times 5 is 10. Cos of 120 is minus a half, so you do need to be good at your exact values here. Cos of 90 is of course 0. When you travel down the curve, you're going another 30 degrees, which takes you down to minus a half. So yeah, minus a half, that times that to make plus 5y, and this is just a quadratic that I can solve. It factorizes nicely, so y is 3 or minus 8, but of course y is a distance, which means it can't be minus 8, so the answer is 3. Quite a nice question. And we're down to the last question, so really well done if you stuck through this. This question is interesting. It's going to be yet another me blagging the whole answer, because I can't be bothered to do it properly, but I think that's what's needed in maths challenges a lot. It's what's needed. So anyway, you have 3 regular polygons, and you're trying to make this polygon as big as you possibly can. Now, what my logic tells me is what I need m and n. I need their interior angles to add up to just over, as little over 180 as I can, right? Because if they don't add up to 180, then this isn't a polygon because it has an obtuse angle. So sure. So they have to be more than 180. They have to curve downwards to make this a polygon down here. But it needs to be the minimum possible one. Now they're regular polygons as well, right? Which means I can actually just make a little table. And this is where me just knowing maths off the top of my head really helps, because I didn't have to work out any of these. Even the heptagon, which I was praying that I wouldn't have to use, I know it's 128 point something. So okay, there's my table for interior angles of regular polygons. And again, I just know those off the top of my head, which made it really easy for me to do this very quickly. Now, I need to add up 2 of them to be as little over 180 as possible. So a triangle and a pentagon won't do, because that doesn't get to you to 180. A triangle and a hexagon doesn't quite, that makes a straight line, so I can't use that. A triangle and a heptagon gets you to 188, which is not very much over 180, so that seems good. Obviously a triangle and anything more would make something bigger, which I don't want. Now what about a quadrilateral and say something else? Well, a quadrilateral and pentagon make 198, but that's more than the triangle and the heptagon did. And so I know that the answer must be using a triangle and a heptagon, which is bad because I didn't want to use the heptagon. But I know those sort of add up to roughly 188. Okay, so I know that this angle is roughly 188, which of course makes the angle inside the pgon that I want to know about 360 minus that, which is about 172. So I'm looking for a polygon with about an interior angle of 172, which means its exterior angle must be about 8. And that's much easier for me to work with because that gives me the number of sides. Remember, p is the number of sides. So the number, I can use the exterior angle formula. The number of sides is 360 divided by the exterior angle, and 360 divided by 8 is 45. Now, that's not an answer, and the reason it's not an answer is because I've estimated all of this, right? Like I've used roughly 128. And it's sad that 45 is between 42 and 50, but I can work out which of these 2 answers it is because I know that this is 128 point something, which means when I've used 128, I've underestimated this sum, which means I've overestimated this angle here, right? Like I've underestimated this, it should be 188 point something, which means I've overestimated that. But then if I've overestimated that, that means that I've underestimated this. And if I've underestimated this, that means that this number should actually be bigger. And if I'm dividing by something bigger, I get a smaller number. So this should be smaller than 45, which means the answer is actually 42. And that's how I did it. If you're not happy with that, I mean, that's the kind of thing that you should be happy with. But if you're not happy with it, you can do it properly, right? Like the interior angle of heptagon is 7 minus 2, because that's how many triangles it has, times 180 over 7. I'm not going to use this about 128. I'm just going to use, well, that's 5 times 180 over 7. So I'm going to do it properly this time. That should be a full equals sign. I don't know why I used a estimation. That's the sum of those two. So 360 minus those two. 5 times 180 is 900. If we take those away, we get this. That means that's this angle. But again, I want to work with the exterior. So I do 180 minus this, which is this. And then I want to do 360 divided by that. And if I do 360 divided by that, it does actually get me the exact answer of 42. So there is a proper way to do it, but you probably don't have an immense amount of time left when you get to question 25. So doing that kind of estimation, and also just knowing these results off your top of your head is going to help you out a lot. And that brings me to kind of the takeaways that I got from this paper. If you're still bearing with me, know your exact values. I think that came up 3 times, trig values. Also things like cos 120, which aren't in the table, but I had to work out, maybe just thinking about the graph in my head. So exact trig values. Be very good at, obviously, non-calculated work, bus stop division, fractions, multiplying decimals, all that stuff. Just be very, very quick at it. It's going to save you a lot of time. Be very aware of the answers. If on a few occasions I got to the answer quicker than I otherwise would have done because it was there, or I managed to work out what I was supposed to do by looking at the answers. So they're there for a reason, not just so that you can circle one. Please use them. You can use them to your advantage. And finally, know as many results as you can off the top of your head. The fact that I knew the interior angle of a heptagon was 128 point something, just without bothering to work it out, really did save me a lot of time in that last question, and allowed me to blag it very quickly. So know as many results off the top of your head as you physically can when you're going into this paper. But yeah, I hope you enjoyed it, and thanks for watching.